Hello, Math Studies students, and welcome to your online lesson. Today we'll be using something known as the sine rule to find sides and angles of non-right triangles. We will know we are successful when we can efficiently find missing sides and angles of non-right triangles. So we've got the sine rule below here, and before we talk about this, let's talk about what we've done previously. We have used sine in the middle of a trig formula to find area of non-right triangles, and then in our most recent lesson, we used something known as the cosine rule in order to find sides and angles of missing triangles. So why do we even need the sine rule? Well, the sine rule deals with a different relationship between missing sides and angles, and we'll look further at that in just a moment. But this is yet another tool, depending on what information you have on the triangle, that we can use to solve. So the formula: in any triangle ABC, the sine of A over A is equal to the sine of B over B equals the sine of C over C. Well, if we didn't have our previous lessons, this would seem like a little bit of gibberish to us. However, we know that big A, or capital A, is an angle. And so if we draw a triangle here and label it A, B, C, we know that, again, A, B, and C are our vertices. Little a, little b, and little c are all across from their capital versions of their letters, and they represent sides. And so if I take the sine of angle A and I put it over side A, I can now set that equal to the sine of B over B. Or I can set that equal to the sine of capital C over side C. Now, you'll notice here in this formula there are two equal signs. You will never use two equal signs at one time. You will either use the first part here, which says the sine of A over A is equal to the sine of B over B, or you will use the second version, which says the sine of B over B is equal to the sine of C over C. Or you can take the sine of A over A and set it equal to the sine of C over C. But again, you will never use all three of these. What we're doing is we're creating a proportion, which is two fractions set equal to each other. And another way to say this is we're dealing with opposite parts. What do I mean by opposite? Well, it's similar to what we did when we were doing SOHCAHTOA. O meant opposite, which means across from. So if I know, let's say, the sine of an angle, and we'll call it A here, and then I have its opposite part, which we would call lowercase a, I can now set that equal to any other side that I have on this triangle. Let's say it was B, and then I could find the sine of an unknown angle. But I have to know one set of opposite parts, a set of things, an angle and a side that are across from each other. And then I can use any other part to find the other missing part here. So to answer this question that we have, how many equations can be created with this formula? 3, right? We can do the A's equal to the B's equal to the C, or the C's equal to the A. All right, well, the best way to get a handle on this formula is to start using it in an example. So for example 1, what we're looking for is the length of AC. So the first thing we want to do is identify what AC is. And that's this upper right side here. I am going to label it with a lowercase x. So we are looking for x. Now, in order to use the sine rule, we have to know a pair of opposite parts. Now, when we were using the cosine rule, we wanted to know two sides and an included angle. Well, if I look through here, do I know two sides? I don't know AC, certainly. That's the side I'm looking for. I don't know BC. That's the side that I don't know. I'm not specifically looking for it, but I don't know it. I have an angle B. I have an angle C, but I don't have two sides that include it. So this is different from the setup that we had when we were doing cosine rule. What we do have, though, in this case, is a side and its opposite angle. or an angle and its opposite side. And as soon as you have some opposite parts, that means you can use the sine rule to find some stuff. So what I'm going to do is I'm going to put the sine of 39, and I'm going to put that over its opposite part, which is 12. Now, before I go any further, you might also see some examples where people do it the other way around. They put the sine in the bottom and they put the side length on the top. That's fine as long as you do that in every part of your equation. So now I need to set this equal to something. I ask myself, what am I trying to find? Well, I'm trying to find x. Is x an angle or is it a side? Well, it's a side. It's side AC. So that needs to go in the bottom of my equation since I put the signs up top already. And then I'm working with its opposite part. Well, what is opposite or across from x? And across from x, we have the 58. However, that's a degree. So since it's sine rule, we have to do the sine of 58. And that's our setup. We have one variable here. The sine of 58, or that angle 58, is across from the x that we're looking for here. And then we have sine of 39. The angle 39 is across from, or opposite, of that side with the length 12, side AB. All right, now what do we do from here? Well, we simply cross multiply. As always, I'm not going to reach for my calculator until my last step. So I'm crossing over the equal sign. So these are the things that we're going to multiply together. So we'll end up multiplying twice, and there'll be an equal sign still in between these two things that we multiply. It doesn't matter which one goes on the left and the right, but I'm going to start with sine of 39 times x. I'm going to put the x first just to make my notation a little more clear so it doesn't look like I'm taking the sine of 39x, just the sine of 39 times the x. And then on the other side, I'm going to multiply the 12 times the sine of 58. Now, there must still be an equal sign when you cross multiply. Again, we were crossing over the equal sign. That's the only time you're allowed to cross multiply is when there is an equal sign between two fractions. All right, what is our goal? Our goal is still to find x. Well, x is right here, and we need to get x alone. What is keeping x from being alone? The sine of 39. So I'm going to divide both sides by sine of 39. And then on the left side, those sines of 39 will cancel out, which was the whole goal of dividing by it. So I have x all alone. And now all I need to do is plug into my calculator all of this stuff here on the right. Now, there is a group here, so when I put it in the calculator, I'm going to put some parentheses around the numerator. So in parentheses, 12 times sine of 58. And then I'm going to make sure to close my parentheses for the 58 that opens up in the calculator. And then I will divide that by sine of 39, once again, closing those parentheses that we get there on the calculator. For a final answer here, or for an answer on my calculator anyway, I get 16.17. And now I want to make sure I round that to three significant figures, and so I'm going to end up with approximately 16.2. And my units on this would be centimeters since we're finding a length of a side. Now we can look back at the picture. We only knew one length previously, which was 12 centimeters. And now we found this side, which appeared on the picture, AC, to be much longer than the 12. We end up with 16.2, which is over 30% bigger. So that seems reasonable. It's not ridiculously large, and yet it seems to be in scale with the rest of the picture. That's an example of using the sine rule. Let's try again. So for example 2, we do not have a picture drawn, so we're going to want to draw one for ourselves. Find the measure of angle L in the triangle KLM, given that angle LKM measures 56 degrees, LM is 16.8 meters, and KM is 13.5 meters. So I'm going to start by actually sketching a triangle, KLM. This likely will not be to scale since I'm just drawing it freehand and not really looking at any of the measurements before I draw it. But I'm going to label my vertices K, L, and M. And now let's see which parts we have that we can label here. So we're looking for the measure of angle L. So if we want to right away, we could label that with like a theta or something like that, or an X. In triangle KLM, given that angle LKM measures 56 degrees. Now again, a quick reminder, when you're given 3 letters here, you can just trace those letters with your finger. So we're going from L to K to M, but K is the vertex. So we know that this angle K is the 56 degrees. We have LM, which is our bottom side here, which is 16.8 meters. And then we have KM, which is 13.5 meters. Now, once again, in order to use sine rule, we have to know opposite parts. Well, right away here, I can see that angle LKM, which has the vertex of K and is 56 degrees, is across from this side that we already know, 16.8. So right away, I'm going to start setting up my proportion where I'll take the sine of the angle that I know, and then I'm going to put it over its opposite side, which we know is 16.8. All right. So again, we have the sine of an angle over its opposite part, and now we're going to set that equal to another pair of opposite parts, but we want to involve something that we're actually looking for. Well, what we're looking for is this angle L here, which we've already marked as theta, and it is opposite of this 13.5, which is awesome. If we didn't have an opposite part, again, we couldn't be using this, or we'd have to do multiple steps on this. So the 13.5 I already know, and that's a side length, so that's going to go in my denominator. In my numerator goes my angle. Now, a common mistake someone might make is they might just put theta up here. However, it's an angle, and in the sine rule, we have to do the sine of the angle. So I'm going to put sine of theta. So that's our setup. Once again, opposite parts getting used here. So our next step is to actually do some algebra. First step, again, we're cross multiplying. We're crossing over the equal sign here. So I'm going to take 13.5 and set that, or multiply that times sine of 56. And then I'm going to set all that equal to 16.8 getting multiplied by sine of theta. So I haven't really done much math. Technically, I've multiplied across the equal sign. I made sure to bring down my equal sign. And now we ask ourselves, what are we trying to get alone? Well, I'm trying to get theta alone. Well, theta is over here. So what's keeping theta from being alone? Well, 2 things. One, we're taking the sine of theta, but we're also multiplying it by 6.8. So we're going to have to do 2 steps to get rid of this. And the first thing I'm going to do is get rid of the 16.8. So we are going to divide by 16.8. And whatever we do to one side, we have to do to the other. So the 16.8s cancel out here on the right side. Now on the left side, we're getting sort of this big, multi-fraction thing with trig ratios in there. But I'm not worried about that at this moment. The only thing that I'm worried about is getting theta alone, and then I'll put everything in the calculator in one step. So we're so close to being alone. I am going to rewrite this very quickly here, just so it's a little cleaner. So you'll notice on the right side, all I have is just sine of theta. Well, thinking all the way back to our trig ratios, how do we get rid of sine? Well, in order to get rid of sine, we have to do inverse sine. So I'm going to squeeze in sine to the -1, or inverse sine, but whatever I do to one side, I have to do it to the whole other side. Now this is where we need to make sure that we're doing parentheses correctly and smartly. We're doing the inverse sine of that whole division problem, which has in the numerator 13.5 times sine of 56, all divided by 16.8. But we want to do the inverse sine of that. So the first thing I'll type in my calculator is inverse sine. Why don't we actually practice that, and I'll pull out the calculator here. All right, so the first thing we want to do is type our inverse of sine, which we get by pressing second and then the sine key. And then we have an automatic parenthesis that opens up. I'm going to open another set of parentheses representing my numerator. And in my numerator, I have 13.5 times, and you don't even have to write the time symbol, but I'm going to put it there just so that I'm thinking about what I'm actually typing in. And then the sine of 56. Now you'll notice once I press sine, a parenthesis automatically opens up, so I'm going to have to close that after hitting the 56. Close my parentheses there. Now I'm going to close a set of parentheses for my whole numerator. Now I'm going to divide this by my denominator, which was 16.8. And I'm going to close my parentheses now, which represents the whole thing that I'm taking the inverse sine of. And press enter. So I end up with an angle that's approximately 41.8 degrees. And that is our final answer here for the angle that we were looking for, theta. Again, I've rounded that to 3 significant figures. All right, so in conclusion, the cosine rule, which we went over last lesson, we need to make sure that we have any 2 sides and their included angle. So 2 sides and their included angle. For the sine rule, we need to have an opposite pair of parts. And what we mean by that is an opposite side and angle. And then we set up our proportion. All right, so 2 sides and an included angle. That's for cosine rule. Sine rule, opposite pair of parts. They both get us missing sides, missing angles, but that is the thing we need to be looking for when deciding which one to use. Till next time.